Everybody, hope you guys are doing well. So continuing our journey, today we will be revising a bit about callbacks, and then we will try to check what the problem with callbacks is, and then we will move on with promises. So callback is basically the callback is basically a programming pattern in which a function is basically passed as an argument to the another function. Now, depending upon the function that which it is passed to, it may be or uh, may or may not be asynchronous. So basically, it is a function being passed to another function. So in simple line, it is just a function that is being passed to another function. Now, depending on the outer function, it may or may not be asynchronous. So it may or may not be asynchronous. So basically, it's the outer function that is going to make it asynchronous, and inherently that is what is going to, for example, set timeout, right? Let this be some other color. For example, one big example is set timeout, right? So what set timeout does is, now this is like it needs hardware access, right? So it needs a kernel call. So what happens is the event loop is responsible, and whatever the functions is mentioned, right? It's like whatever is mentioned, that that execution is delayed until you have the timer which is being until the timer expires. So here you have a timer, right? So until this timer expires, the execution of that inside function will be delayed. So it's basically the set timeout, because this is asynchronous in nature. And what is happening is, because this is async and we need hardware access, or we need kernel access, and we are going to go out and refer to the um, that is what is going to make this callback to wait and return after this is being after this timer is expired. So this set timeout is making this synchronously to wait. And there is a problem with callbacks, right? The problems with callback is basically, first is callbacks cannot be trusted. Second is, the more use of callback we have, the more we are going to perform nesting, right? Basically, we are going to result in a problem called as callback hell, which will make debugging our code very difficult, right? To solve all this problem, will make use of something called as promises, right? And the promises, what it does is, uh, promises will, as the name suggests, it will promise us, and it will make sure that the desired function is always executed, and there is no there is no delay, or it is like a promise, right? Like a pinky promise that you make, and it will 100% make sure that the callback present is getting invoked. The first problem of callback is callback error, right? These are all basically async operations, right? For example, you are reading a file. So what is happening is, you are increasing the nesting here. So this makes the code very unreadable, right? So it is like very difficult to understand and read what this piece of code represents. Now, So since it is very difficult to understand, debugging the code, for example, if we have a error in this line, then we need to pass all through down and to check, we need to check all what the behavior is happening, which is being it's not legible at all, right? It's very difficult to say, very difficult to point the error in one go. No, when callbacks fail. Now this is another one big problem, right? So callbacks can fail. So what if, inside a set timeout I will call this, I have an if condition and only then I'm going to call. So if this condition is not satisfied, now this is math.random, right? It produces any random value. So any random value will be produced. So the probability is like 50%, right? So one chances that this we might get something which is greater than 0.5, and the other possibility is that this might result in a value which is less than 0.5. So then if this condition is not satisfied, this is never going to be called, right? Because we are not going to go inside the loop. Even if the timer expires, still we are waiting for this if condition to be held true, right? If this doesn't happen, then we won't go inside. Okay, the third disadvantage, like the third disadvantage is, since callback are just like functions, right? So sometimes it may happen that we may forget them, and then instead of using it asynchronously, we may use it synchronously. So this is just like a normal function call, right? So it is the outer function that is making the callback to be called asynchronously. Okay, one biggest drawback is the context is lost, right? Since this is basically a function, so whenever we make a set timeout call, so the this binding is lost, right? So we need some sort of way to make sure to remember that we are referring to this instance, or we are referring to the current instance of the amount, right? Because whenever you make a callback, this especially happens when you have an anonymous, right? The problem is anonymous or arrow functions cannot retain the scope, right? So that is a very big drawback, right? So so that what we need to do is we need to locally store this binding somewhere, or like basically we are increasing the complexity of the code, right? We need to do a closure binding, or we need to adopt some method using which we can store this locally, and only then will we be able to achieve this binding. A callback in a loop. Now one more drawback is, so since there is no this binding, like I will all, because there is no this binding, right? So we don't know which instance are we referring to, so it will always print 5. So this is another big drawback, right? That is another big advantage of using. Okay, so the this context is what happens is, whenever you have a function called, the what does the function do is it kind of retake creates an own this binding, right? We don't want the function to refer to its own binding. Instead we want to refer to this object that it is which bind it to. Hence what is happening is the context of the original object is getting lost. Now arrow functions do not create their own disk binding, unlike regular functions. Instead what they do is they inherit this from the lexically captured scope, right, where they are defined or where they are maintained. So if there was no this binding, if there was no arrow functions, previously what we used to do is we used to locally bind this, right, so that the function does not loses the concept. Or explicitly we used to create the this binding, because since function is an object, it creates an own this. So when you have a function, the this is referring to the function instance and not to the object that we want to refer, right? So this is a very bad issue, right? Because functions are first class citizens. Instead of binding, uh, to the object where it is called, what will happen is the this will refer to like it will refer to the function itself, because functions are first class citizens. Like we need to explicitly, if you are calling any function and you need to explicitly bind this, right? The problem with this is the value of this will change depending upon how the function is getting called. Because if you just mention callback, then this is going to refer to the global object and not to this scope or the object where we have defined. Okay, so let's see a little bit more about this binding, right? Now see, so what happens is, now since now this basically refers to the object that is currently executing the function, but its value, so this refers to the current object. It refers to the object that is executing the function, but the value of this will depend on how the function is getting called. So the function call plays a very important role in defining this, right? If we define it object dot function, then the this binding will be to the object where it is called. If you do not do the this binding by default, then it will refer to the global object, right? So once it refers to the global object, then the this reference is lost, and we don't want that to happen, right? So to avoid this, what we do is we explicitly bind this by making sure that we are calling the function in a proper way. Like you are calling the function with the object name in front, or you are attaching the object binding to the function. Now the advantage of arrows is arrow function kind of so in arrow functions, this will behave differently, right? What it does is, now here we need to attach, right, but arrow functions will kind of automatically link to the link this or bind this to the scope where they are getting declared. So there is no need for us to worry about the this. Okay, now there is one last thing, that right, a callback can execute multiple times, right? Now the okay, the drawback is here is okay, the drawback or the main issue is since the binding does not happen, right? So we okay. So for example, this is like a process payment, right? So we are going to call this function, right? This is my process payment function, and this is basically a callback. A callback is nothing but a function that is being passed inside a function, right? Now, there is, what if both the user exist and there is no error, right? So we'll come here and we'll make a call to this callback. Now the problem here is this callback won't have access to the binding, right? So then instead of making one call, what we will have is we will like this is the same data needs to be printed here, right, in send receipt. But then what may happen is, since the binding is not retained, so this send receipt may print something else, or it may lead to possible two deductions. We don't want that to happen, right? So hence, instead of calling it once, the callback is getting executed multiple times, even though we didn't want them to execute multiple times. Now there is some wait. Uh, so your callback is getting executed multiple times. Like instead of executing it one, how is that happening? Okay, for example, in set interval, right, that event will keep on firing itself. You need to add some guard, right? You need to do clear interval, else that callback will be called multiple times. Mm, okay, so the better example of understanding callbacks being executed multiple times is on the event listeners, right? For example, this is my button. Okay. Uh, this is not. I mean, so the multiple callback has nothing to do with this binding. That is altogether a different thing. Okay, let's have this. Let's make it white. Okay, now, so this is a button, right? So this is a button, and suppose this is the submit button. Now, the moment I click this button, this is going to get logged, right? Or so this is my, I'm adding the event listener onto the button, and then this is the solution. Okay. So when I'm adding on, so whenever I click this button, the handler is, which is this, is going to get called, right? Like what if I make multiple clicks? Like what if I happen to make so at times we get agitated and we try to press it multiple times, right? Every time we press it, this handler is going to get triggered. So like just assume this remove event listener is not present here. That is basically kind of solving the issue. So the moment we press the button, this handler is going to get triggered, right? So if we don't do something like remove the event listener when we don't want it to function, then this will get triggered multiple times irrespective of the time that we only wanted to click it once, right? And we don't want multiple, because that will lead to a processing error, right? You will keep on calling, then you will end up in that pyramid. So to avoid that, we kind of clear things out before we are but this is again not a very rigid solution, right? This can be, it can be like we can break the code, right? So the the solution to all of this is use promises, right? So promises will make sure that we get the intended output and it will work as we need it, not how and like there won't be any issue, right, with them. So the solution to this is use promise, right? Now let's see how can we use a promise now. Okay, now using promises, right? When the advent of promises, now this came in ES6. It's a very new way. Now web browsers have begun to implement promise based APIs. In the previous section we implemented that made an asynchronous HTTP request. So now what is going to happen is how is promises going to resolve all of them. Okay, let's see. So promise terminology. Now before we study promises, there are certain terms that we need to understand. Now when we are not programming and we talk of promises, we say that a promise is kept or broken. When discussing JavaScript promises, the equivalent terms, so we have so yeah, in human language you have two terms, right? Suppose I'm making a promise, right? So this is a, you make a promise, so then there are possible two ways, right? Either you so either you break the promise, so break the promise, or either you complete the promise, right? So in both term, even we when we, okay, we'll see what happens when we break, or when you complete the promise, right? So completing the promise is basically called as successful, or it is called as a um, this is called as a success. And when you break the promise, that is nothing but called as failed state. Now even though we are breaking the promise, we'll see like why is still, if you are breaking the promise, then why is still promise going to work. Now promise is an object that represents the results of an asynchronous operation. It is important to remember that these are not abstract ways of representing callbacks to run somewhere. Now they represent the results of the async code. If the async code runs normally and the promise rule, then that result is essentially the return value of the code. If the async code does not wake or complete and the promise is rejected, then the result is an error object or some other value that the code might have thrown if not asynchronous. Now any promise that has settled as a value associated with it and that value will not set. If a promise is fulfilled, then the value is a return value that gets passed to any callback function registered as the first argument of then. If the promise is rejected, then the value is a catch of some sort. Okay, so if we have a failed state, we are going to return an error, right? So to catch that error, to have or to perform graceful termination, we will do catch, and then if it's a success, then it will be passed on to the then method. So that return value of the promise is going to pass to the then method, right? Now let's see how let's understand how promise is going to work, right? Now remember these are all async functions are all API, right? Okay, so for example we are making a function call, right? Now what the function call will return is a promise. Suppose we write a code. Yeah. So suppose we make a function call. So we make a function call, and this function is going to return us a promise. And there are two possible states here, right? One, it is one if the promise is fulfilled. So here, is if we have full if we have promise for being fulfilled, and then the other we have is some error or rejected, right? Okay, so now in case if the promise is fulfilled, then whatever this fetch is going to return, that return value will be automatically passed to the then method, right? And if this is an error, so whatever error we get after this, that will be passed to the uh, catch method. So you have the catch method for uh, 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 for performing that, right? Now what if this then method also, what if it is returning a promise? So you have two possible. So what if you have something which is returned from this, and then when you call inside this, you are again going to like it is again going to give us a promise. What if some statement is returning a promise inside here? So there are again here two things, right? Either it will be fulfilled, or either it will be rejected. Now, so again, so whatever, if it's fulfilled, then the return value of this will get passed to another then which is changed to it. So you will have then being present here, and if the return value of this fails, then you are passing it to the catch, right? So you are going to get another catch which is going to catch this error. Now, let's understand more deeply, like rejected and fulfilled promise. Huh. Now let's see, like these terms. So if the promise is getting rejected, then why do we? So basically, what we are making sure is there will be two states, like for every promise. Now in call, we are making sure that we are getting some sort of execution be completed, right? Either it is fulfilled or it is rejected. But in callbacks, what happens is it may or may not return us a value. Like if it's a very deeply nested callback, then we may not get any value. So again, we are stuck over there, right? But we are making sure, explicitly making sure that either we get a fulfilled value or we get a rejected value. Okay, now let's see some yeah, because so even this is considered as a valid state, right? Although in our code we might not get the desired output, but we are saying that every promise will mandatorily return either of the state. Either it will be a fulfilled or a rejected state. If it's a fulfilled state, then whatever is being returned, that will be passed on to the dot then function. If it's rejected, then it will be passed on to the catch function. If for example, let's see, let's see some examples, right, of using promises. For example, so basically, the goal, since promises solve that problem of callbacks, right? So mostly, like most programs these days make use of promises, right? Okay, so now, for example, most web APIs have promises being incorporated, right? So whenever you make an API call, so this is fetch. So first, this is my fetch call. Now what this is going to do is I'm going to make a call to an API, right? Once I make that call, so this is going to reject a promise. So I'm explicitly stating that this is going to reject my. Okay, so let's have it. No. Mm, I'm going to say this is going to return promise, right? Now this promise can be of two. So you can have possible two things happening here. Either you get fulfilled promise, or either you get rejected, right? Okay, so let's. So either we could have a fulfilled promise. So this is fulfilled, and then either we could have a promise which has been rejected, right? Now, if we have a promise that is rejected, then we need to handle it. For that, we need to have a catch method, right? So whatever is getting returned from this will be taken and as the parameter to this method. Now, if it's getting fulfilled, then we will have the dot then method. So whatever is getting returned will be passed to the then method. So you have the then method being presented. Will be passed as a parameter to the then method. Now, what if uh, okay, so what if we have another what if this then method is going to make another what asynchronous operation? So again, you will have two more branches out of it, right? Either you will have a then, and then other you will have either you will have a then or you will have a catch. So what is happening is when the fetch is fulfilled, it passes a response. Now this response gives you the access to the request status, and the result also defines the methods like text and JSON, which access to the body. Now, but although the initial promise fulfilled, the body of the response may not yet have arrived. So the text and the JSON methods for accessing the body of the response return promises themselves. So if they are going to return a promise themselves, then I need to handle that promise. Okay. This is how basically we need to nest a promise, right? Now, one other thing that we have is what we see, we are going from uh, one promise to another, and that is kind of okay. Let's see one more example where we have a chain of, okay, so let's see. Okay, this is how my promise chaining is going to happen, right? Okay, so the moment I create that promise, initially it will be in the pending state, right? Yeah, so this is okay. So promise chaining. Now this is going to return a promise, right? This is my first argument that I have passed. Okay, so this returns a promise. So here I'm going to have a promise being returned. So if this is a promise returned, then I need to we will have two more things, right? We'll have to take care of the then method, and we have the catch method, right? So whatever it is being returned will be passed on to the then method, and if there is an error, then that will go to the catch method, right? But then there is one caveat, right? It's instead of writing the catch at every line, you can just have add it at one of the end. So even if there is an error at any of these, the remaining promises won't be called. We'll directly go to the catch. Okay, now Now this then is again going to return a promise, right? So then I'm going to handle it calculated as well. Um, so I'm returning again a new promise object, right? So whatever is going to return, that is being passed to the display result dot then, and then so the display result is not returning any promise, so then I'm okay with that. And then I'm passing in the resolve object, right? So if the promise is resolved, then you now the dot then method kind of functions differently, right? If it's a promise which is being returned, um, if it's a value, if the handler returns a value, that is automatically wrapped in a promise. If it returns a promise, then the chain will wait for it to resolve. If there is any issue or any rejection in the chain, the catch will be called. So even the value will be so whatever value we get here, that also is wrapped in a promise. So first I'm going to make, okay, this is going to call get user. So I'm returning a new promise object, and then I'm going to set timeout, and then so I'm going to wait for and then I have my get orders being called. It will wait, right? For so the dot then will wait. So if the moment this gets resolved, then I'll be returning. So I'm having, okay, this is my callback, right? So I'm going to resolve. mm, I'm passing in, so this is basically returning a new promise. Okay, so what is being returned here? Okay, if it's single function, then we do not need to yeah, this new okay, we are wrapping this as a promise object. So I guess this is the return value. Resolve, set timeout, and which is coming here. So here I'm getting get orders, right? So I return this. So I'm going to return this promise, this big one. Uh, when I'm coming to the then handler, okay, First, I'm going to get user. This is a promise, and then I'm having this function which is present inside, right? And then so what will be passed is I have resolve. Let's see this result. What is that doing? Resolve is a critical part of promises work. Now, resolve is the function that automatically provided you when you create a new. So I create a new promise. So I have two functions, right? Either I can resolve it or reject it. If I resolve it, okay, so whatever is passed inside the resolve is my return value. Okay, so this is going to return a new promise, right? And then the moment I create a new promise, I have access to two things: reject and resolve. So then I'm going to set a timeout, and I'm going to wait for this timeout to expire, and then whatever is inside the resolve will be passed. Okay, let's see. Okay, there is something called as when we explicitly do resolution of a promise, right? Okay, let's see what how it's going to work here. Let's make it medium. Zoom in. No. So this is basically creating a new promise object. So then the moment you say this new promise, so then so this is max man explicitly creating it. So the moment you have this new promise, then you are going to have this so inside the new promise object you have a function, right, that has two parameters, reject and resolve. Now this is basically you have access to this function, right, and whatever is passed in this resolve, so once this delay of 1000 is over, this is going to get returned. Let's see the promise object. Because when we make an API call, we don't uh, do the manual thing, right? We already have. Okay, so the under the hood, the manually, oh sorry, the way the promise is is represented is you have this. So basically, it takes in a callback, and this callback returns two possible values here. Either if it's a success, then it is going to it is going to return whatever this value has been passed in here. If it's a reject, then it is going to return whatever this value have been. So what is this results on reject? So basically promise now. So I have on. How is this? If the promise, okay, so this resolve is getting whatever is passed here, that will get passed to the then function, and then this is going to get passed to the catch function, I guess. I have okay. No, see, it's little bit more in detail. So this is how is the structure of a promise object, right? Internally, it is built this way. So you have this. Okay, this is I'm going to create the instance of the promise, and whenever I do, I'm going to create a new promise object. So and then I'm going to have so basically this is how that so then now so how are the instance methods being located? Okay, so you have instance method, right? So let's do now. So remember, this is the instance that we created. So we are calling this promise, and then this is dot, right? This is how instance methods are invoked, right? And then you have two things. You have on fulfilled and on rejected. So this is an optional value. Either it can be true or it can be false. Now, if this is true, then if it's a value, this is an arrow syntax. This indicates that a promise will be returned here. Okay. And both of these handlers are options. So either you can have them or you don't have them. That's okay. If it's on fulfill, then you return the value. Oh, either you return the value or basically you return the new promise. So ultimately, that value which is returned is also be going to get wrapped in the promise. If it's rejected, then you have this, either you return the value or a new promise. Now again, promise.catch, this is again an instance method, right? So the way this would be written is it would be present on the instance. So this is going to be my instance because I'm going to call it using dot. So whenever you call something using dot, that is an indicating that this is an promise instance. Even this is a dot thing, right? So this is, I'm calling it on the promise instance, and then Okay, so and then what does this do is, even this is going, so this is an arrow syntax which indicates that a promise is being returned. So when this is on rejected, I'm going to have this being given out. Let's see the promise class. That will be more. So inside ES6, when classes and objects came into picture, the promise was introduced, right? So let's see. Okay, so let's see how. Yeah, so this is how internally the promise class is. So in ES6 is when we got promises, because previously to that, JavaScript was mostly prototype oriented language, right? That is when OOP or class based object oriented programming was introduced in JavaScript. So first is basically a constructor, right? So this is my constructor call. Now you have a different, so methods which are directly written inside are called as instance methods. So as I have catch, this is a static method. That means this one, for invocating this method, you do not need to use the instance. You can directly call resolve. Now again, this is a static method. You do not need to invoke it using the instance. Now these three all are instance, right? So the moment you create an instance, you need to refer that instance to call this. Okay, now this is the constructor. So the constructor is going to call when you create the object. So when you create the object, the constructor will mandatorily take in a function. Now this is this is so which will have two parameters. This is these both are optional, and then you have something called as, so this is the return value, can be or cannot be okay, because yeah, this return value is going to be void. Now what is executor? This is something. So executor, the way it is going to work is okay. Now let's see about executor function. The executor function is a critical component. uh, Executor is the function you pass to the new promise constructor. It receives two functions as parameters. uh, so I have two functions that are being, so these resolve and reject are two functions that are being passed as parameters, and then this is going to return. Why is executor working synchronously? The promise is present in even loop. So the moment you see this promise class, it will take out the code and it will. So our that resolve and reject functions that is passed to the constructor. Okay, so promise is basically a class that has been implemented. Hmm. And promise is present in the even loop, right? So we can say that is promise object is present in the event loop, which makes it asynchronous. Yeah, it's like it the micro task queue detects, right? We have set timeout and so again, promises. Because in callbacks we said it's the callback or the it's the outer function that is uh making the async thing to happen, right? Hmm. So I guess this is all for this lecture. I'll see you guys in the next one. Till that time, take care. Bye. We'll continue with promises and we'll try to understand in detail why promises is supporting asynchronous. We'll see that. That's all for this lecture. See you guys in the next one. Till that time, take care. Bye bye.